Right, so point, line, and plane. So how would you describe a point? Like, if you're trying to describe it to a younger sibling or something, somebody maybe in elementary school, how would you expound on the point?
It's a dot.
It's a dot. Okay, yeah. So literally, I mean, in all these definitions on the top here, you could probably just draw a picture of it by doing that. What does that dot do? That dot, does it really have like length and width? Does it have an area to it, that dot, or it's a term or location? Yeah, that's a good way to describe it, because it is. Visually, it's a dot, but a dot literally has area to it, right? But we don't treat it like that. It's just a location. Okay, so that's really what a point is. It is a, it's a place in space with no dimension. Okay, so there's a place in space with no dimension. You could, and I would encourage you actually to draw a little picture for each of these. I don't know if you need to for point, but it's a place in space with no dimension to it. Then a line. You know, if you take a couple of dots and you place them, you know, on this plane. Here I have a plane. So I have a dot here. There's a location. There's another location. By the way, how do we label points? I mean, we could. Yeah, usually with letters, capital letters, A, B, C, D, and it seems to be the easiest way to locate a point. Now, points on the Cartesian coordinate plane, you know what the Cartesian coordinate plane is?
It's the one with the four
It is. Yeah, we call those quadrants, 4 quadrants. And I feel like I have to, like, it's been summer and stuff, but yeah, the 4 quadrants in the Cartesian coordinate plane, they all have an X and a Y, right? So instead of describing them necessarily with an X and Y, we can just use a letter to describe them. That's probably the simplest way. Typically, we do have something associated with them, like 5, -3, tells you to go 5 right and 3 down, so forth. But if you take 2 points, call them A and B, and then you connect the two, we have what's called a line segment. A line segment is a line that has endpoints on it, right? It stops at A and B. If I wanted to truly draw a line here, what I would do is go ahead and extend through the point a little bit, put an arrow there, extend through that point just a little bit and put an arrow there, and now it's a line. And what do those arrows mean? What are they telling me? It keeps going on forever and ever, but I just can't draw it forever, right? So we put the arrows on it to show. So that's what a line is. Line segment. Oops, switch back here. Line segment is a part of a line with endpoints, and I showed you that first. The line segment was the part of the line with endpoints. And when it comes to a line segment versus a line, we have different symbolism that we use. Okay, if I want to talk about line AB, I go ahead and write on here. Different color. I write AB and I put a little symbol over the top that has arrows on each end. As opposed to line segment AB would look like this. I'd write AB and I would draw a line segment. Notice there are no arrows on the ends of the line segment symbol. So there's a difference in the symbolism for line versus line segment, and also there's a difference between those two and the symbol for array. Okay, array may be new for you, I don't know. An array is defined to be, it's a part of a line, but it has a starting point and then goes on forever the other way. So it has a starting point, then goes on forever the other way. And it has its own symbol as well. And so we would write here AB and then place the array symbol, which has a starting point over here on the left, and then goes forever, in this case, towards B and beyond. Okay, this phrase opposite rays shows up here in the textbook. I haven't seen that phrase show up very often in mathematics, but opposite rays are, I think, what you maybe are thinking they are. If you put 2 opposite rays together, what do you think you have? A line, yeah. And so it is what you think. So opposite rays, got a definition here. It's two rays that share an endpoint and go in opposite directions to form a line. So two rays that share an endpoint. So let's share an endpoint here. We got a shared endpoint, and then they go in opposite opposite directions, so to the right and also to the left, and they do form a line. So those are opposite rays, and they have this central point in common here. And so rays, when you use this symbol for rays, you can use it to show which way you're going towards. Like if the line keeps going in the direction of, say the line is going in the direction of A, I could go like this. It would mean the ray is starting at B and going towards A and then through A and beyond. So opposite rays constitute a line. So we've got point. Point was just a place in space with no dimension. And then we have a line, but lines are made up, they could be line segments or rays. We have different symbols for each one. And then the next one, we now go to from one dimension. Line is one dimensional. Point, no dimension. Line, one dimensional. Right? It's just a length. If it's a line segment, you can find the length. And then the next one up is two dimensional. It's a plane. How do you describe a plane to some, like a younger sibling?
It's like a shape.
Okay, sure. It's hard to describe even what the shape is. I mean, we can actually use triangles or rectangles or other shapes. It's just, but the idea is it's flat. It does have two dimensions, right? It is infinite. That's the tricky part. Because so you can even use a triangle to represent a plane, but you got to understand that it just keeps going forever in each direction. Like a triangle would have three pieces to it, and it would look like you can have a triangle, but then it just keeps on going. You know, in this direction, just keeps on going forever in that direction, in that direction. So this entire board right here, we would consider it a plane. Or that entire back wall is a plane, or the ceiling is a plane, right? But even the ceiling, we could consider that there's a plane, it just keeps on going in each of the four directions forever. Whereas there's another plane represented by this wall here, vertical to the ceiling, that also goes in every direction, right? So we have different planes, and we can talk about points being in the same plane or not in the same plane and so forth. But a plane, let's see what we have for a definition here, is a two-dimensional surface. And it's important to understand that it does keep going on forever in each direction. So two-dimensional surface for a plane. And we can have points in different planes. Like there are points in the plane of this ceiling. Like you could think of maybe each of the intersections of these little metallic kind of the framing pieces that hold in the you know, parts of the ceiling here. But there are points there, and then there's points that we could locate even on this carpet on the floor here that are in different planes, right? And so we would actually call the points up there, the points down here as non-coplanar. They're not in the same plane. Okay. We can also talk about collinear points versus non-collinear points. What do you think collinear means? You know what the prefix co means? Yeah.
Same line.
Same, yeah, on the same line. So co means with or together. And so collinear means points on the same line or segment array. Points on the same line, segment array. Coplanar would mean points on the same plane. And then whether we're talking about lines or planes, you can actually reference or talk about them intersecting. You've studied in algebra intersecting lines. You've actually learned methods for finding where they cross, right? There's either substitution or elimination or graphing. You remember those. if you had a whole unit on finding intersections of lines. So lines can intersect. Planes can also intersect. We can see here, I've got the plane of this front wall with this side wall, and they intersect right here at the corner of the room, right? And so their intersection, these two planes intersect and make a line. They intersect. Whereas two lines intersect at a point. Right? But you can talk about intersecting planes as well, if you can lines. But to intersect means two figures have at least one point in common. So then it applies to lines or to planes. So trying to give that picture a three-dimensional effect. You're going to practice this in the practice problems in the book. So here's the type of thing you'll be asked to do. It's basically applying these definitions, checking for understanding. So what are three collinear points in the picture you have on your note packet? Def, that's right, DEF. So the way we would write it is D, comma, E, comma, F, D, comma, E, comma, F. So referring to the 3 points that are all on the same line. What about 4 coplanar points?
Good day.
Good depth, yeah. So throw in G with D, E, and F, and you have 4 coplanar points. All right, and then name 3 points that aren't collinear. So we need to name maybe 2 points that could be on the same line, and then maybe 1 point that's not. So if we throw in with D and E, maybe throw in G. That would be one way to do it. So 3 points that aren't collinear, we have D, E, and G. D and E are collinear, but G is not. And then they ask us to kind of read this symbolism. Hopefully you can read it here. There's a bigger one here. There's an arrow on LJ. When it comes to KL, it should be a segment. On your KL, there's 2 arrows. Change it to just a segment. Put dots on the end, please. So on KL, just put dots over those arrows so that we have one of each. Is that right? So we're going to go ahead and draw J, K, and L that are 3 non-collinear points. So J, here's J, here's K, here's L, and we're going to leave the arrows on JK. We're going to draw a line through JK. So I'm just going to draw a line through JK, it has arrows on each end. And then you're changing KL to just a segment. So turn those arrows once again into dots on each end. And so KL, we're going to make it a segment. So it would start at K and end at L. And then if LJ is a ray, I'm going to start at L, and I'm going to go through J and then put an arrow on the end. So that's just reading the 3 different symbols. That's probably what you'll use most from this lesson, just the symbolism, being able to notice the different symbols between a line segment, and ray as we move forward here. So any questions on that? Okay, I have a little activity with you. Check here. Good.